Welcome to our series on polynomials. In this video, we will discuss how do we easily calculate average rate of change and instantaneous rate of change. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to take up IB test question based on polynomial functions. We'll try to find what is the average rate of change and what is the instantaneous rate of change for the given function. Let me first thank all the viewers and subscribers for watching my videos, posting excellent comments, and sharing some brilliant questions. Based on your questions and suggestions, we are developing videos for you absolutely free for last 15 years. Now we have more than 17,000 videos. I hope you are enjoying this journey of success along with us. Well, in case you want to learn from me, feel free to send an email on the address given globalmathinstitute@gmail.com. Thanks for your support. Now let us see how do we answer the question at hand. Find average rate of change for x belonging to closed interval -1 to 2 and find instantaneous rate of change at x equals to 2. Function f of x equals to 5x cubed x minus 1 whole square. Now, what is the average rate of change? Let's start with there. Average rate of change is between any 2 points. It's like slope of a secant line, right? So let's say the points are A and B, then the outputs f of b minus f of a over b minus a gives us the average rate of change. Now, in this particular case, we are given the points as from -1 to 2. So, what we will do here is find the value of the function at -1, right? That is to say, substitute -1 for x. So, we have 5 times -1 cubed and then -1 minus 1 whole square. Now, this value, as you know, is equal to, so this is -5 and -2 square will be 4, and that gives you a value of -20. The other one is f of 2. So let's plug in 2 now, and we get 5 times 2 cubed times 2 minus 1 whole square. So 2 cubed is 8, so 5 times 8, and this square is 1, and this value therefore is 40 for us, correct? So once you have found these values, not difficult in this case, easy calculations, we can now find average rate of change, right? And that between the two given points will be f of 2 minus f of -1 divided by 2 minus -1. Perfect. So we have 40 minus of -20, correct, over 2 plus 1, which is 3, correct. So that gives you the value, which is 40 plus 20 is 60 over 3, and therefore it is 20 as the average rate of change between the given points. It definitely gives you the slope of the secant line between the points, right? So I hope this concept is absolutely clear. Simple calculations, and now you can actually find the instantaneous rate of change at x. Perfect. So I hope it is clear. Let's move on and find instantaneous rate of change of the given function at x equals to 2. Now, how do you figure this out? There are a couple of methods to do it. So we have a method which is called following method, one is preceding method, and one is central method, right? So we are going to use central method in this case. We need to find the instantaneous rate of change. I'm writing this as I rock, as between at 2, right? So at 2. So we'll take a point which is very close to 2 on left side and on the right side. So when I mean left and right, it means what? X value being equal to 1 point, let's say 999. So this will be on the left side, right? And x equals to 2.001 will be same distance on the right hand side. So that will give us the instantaneous rate of change. They're very close, so it is always an estimate, right? So in this case, we will say, well, because the point is 2, we're actually writing the function as 2 plus some delta x value, right? Minus f of 2 minus delta x value, correct? And when you divide this between 2 plus delta x minus this, we get 2 times delta x in the denominator, and that gives you the instantaneous rate of change. Perfect. Right. So we can do the calculations. We will do the similar calculation, write the function f of x, and substitute the value 1.999. It'll give you a very accurate result, right? So 1.999 whole cube times 1.999 minus 1 whole square. Calculate this value, correct? Similarly, we can now write the value of f of x at 2.001, right? So 5 times 2.001 whole cube times 2.001 minus 1 whole square equals to, right? So use a calculator to find this. My calculations could be wrong, so don't really trust them so much. Do your own calculations, find your own answer, right? Okay, great. So the first one I get here is 5 times 1.999 whole cube, right? And this is going to be multiplied by, within brackets, 1.999 minus 1 whole square. And I get a value which is 39 point, write it to 4 decimal places, okay? So 39.86019, I'm rounding it to 2, correct? Now the next one is 5 times 2.001 cube, right? So we get the number, and then that is to be multiplied by, within brackets, 2.001 minus 1 whole square. And that gives us a value which is 40.1402, right? So that is what we get. Perfect. Now, the instantaneous rate of change, let me write down here, is what? Instantaneous rate of change is the difference of these two values. So I'll write 40.1402 minus 39.8602 divided by difference between them. I could write like this also, right? 2.001 minus 1.999. Makes sense, right? So delta x in our case is 0.001, right? So we are taking delta x as 0.001, right? Now let's calculate this. So we have 40.1402 take away 39.8602, correct. And this is going to be divided by 2.001 minus 1.999, put it in brackets, okay, and then calculate. So I get 139.99, so I'm writing this to 140 as our answer, correct? So we get the value as 140. So this is an estimate. So instantaneous rate of change at 2, x equals to 2, for the given function is 140, a very steep tangent slope, right? So I hope the calculations are easy. I will suggest always in your test, do these calculations separately, show your work, right? In that case, if something goes wrong in calculations, right, you still get good marks, right? That is the whole idea. I hope with that you have understood how do we find the average rate of change between any 2 points and an instantaneous rate of change estimate at a given point. Perfect. Feel free to share my videos, like and subscribe them. In case you want to learn from me, you can always send an email on globalmathinstitute at gmail.com. Your channel, your suggestions. Thanks for your time. Thank you, and all the best.